Good morning, everyone, and welcome to this session, Disaster Recovery Strategies for SQL Server. First things first, please do leave feedback for the session. Let me know what you liked, what you didn't like, so I can improve as a speaker, and I will put this QR code back up at the end of the session. Just a quick little bit about myself first. My name is Andrew Pruski. I am a Field Solutions Architect at Pure Storage. Before that, I was, for my sins, a SQL Server DBA for around 15 years. I'm originally from Swansea in Wales. I've worked in companies in the UK and over in Ireland, where I've been based for the last 10 years, in a range of environments where we've had production environments with literally just 1 or 2 SQL instances. And then I've worked in environments where we have hundreds of production SQL instances. And as you can guess, disaster recovery strategies varied wildly between the two environments. I'm a Microsoft Data Platform MVP, Docker Captain, VMware vExpert. Basically, I am a massive SQL Server nerd. And my contact details are on the slide there, at DBA from the cold on Twitter, and dbafromthecold@gmail.com. So if you have any questions after today, or if you just want to reach out and chat about stuff, please feel free to reach out. I'm always willing to talk about this stuff. Blogs there as well, dbafromthecold.com, posted multiple. I'm kind of a containers Kubernetes guy. But I've posted multiple articles from anything that takes my fancy. You're more than welcome to check that out. And I've got a GitHub account as well, where I will post a QR code and a link to that at the end of the session, where I've got a whole bunch of resources on different technologies and slides and things like that for disaster recovery strategies. So, on to the session. The aim of today's session is to talk about everything around disaster recovery. So it's time to think about how SQL Server is going to fail, how we can test it, the technologies available to us in SQL Server and outside of SQL Server as well. And then we'll have a look at an area that really interests me, chaos engineering, testing our disaster recovery strategy. But there's one thing, if there's one thing that I want you to take away from today, it would be that you need to have a disaster recovery plan in place, and it needs to be tested regularly. I've worked in companies where there's been no DR plan, and we're just winging it. Hey, we're in a private data center. We don't need a DR strategy. That's all handled for us. But unfortunately, hope is not a strategy. And that is, if you Google it, it comes up with a traditional SRE Team motto. And I might be showing my age here when I think, traditional SRE Team motto? Anyone who says that works for Google, so I call it a Google SRE Team motto. And it really isn't. We're not hoping that things are going to be fine. What's the old IT adage? Hope for the best, plan for the worst. Hope is not a strategy, because there are companies out there that have had issues. First one, Netflix. In 2008, August 2008, Netflix experienced a 3-day outage that resulted in them being down completely. And that was back when they were sending DVDs to customers. Can you imagine if Netflix went down for 3 days now? Could you imagine if Netflix went down for 3 days during COVID? There'd have been riots. But Netflix are an interesting case because they came up with a solution and a strategy, and we'll talk about that a little bit more at the end of the session. But loads of companies, Facebook, GitLab. GitLab are really good. Well, in 2017, had a replication issue mixed in with some human error that resulted in massive data loss. But their response to it was fantastic. Did anyone see it? Back in 2017, they actually live streamed their recovery process. You could go on a YouTube channel and watch them recover. Really, really good way of responding to an incident. And it also showed a really good company culture, I think, as well. But Google, Twitter, AWS, Slack, Apple, Microsoft, all of these companies in recent years have had issues. So we got DBAs in the room? Hands up? Oh, right, okay. Awesome. That's what you get when you run a session called Disaster Recovery Strategies for SQL Server, I guess. We're not hoping that our environment is going to stay, because if it's going to happen to them, including Dropbox, Zoom, Adobe, Salesforce, guess what, everyone? I'm not trying to be a harbinger of doom here. I'm not trying to be overly negative. But it does happen. It's happened to me. I've had 3 major outages in my career where I've had to invoke a DR strategy. And I've had all sorts of bonkers responses to when I've gone into a new place saying, we need to start thinking about DR. I had one guy say to me, we'll use our staging environment that's in AWS. We were on premises, big, beefy physical servers, and he wanted to use staging, which had half the resources, and just back up and restore into it. Really? So we need to be thinking about how we're going to recover when SQL Server fails, because it's not a matter of if, it is a matter of when. So what can we do? Well, plan, test, plan, test, plan, test, and so on, and so on, and so on, and so on. Am I showing my age again? We need to put the disaster recovery plan in place, recovery strategy in place, and it needs to be tested regularly. Now, this is difficult because it can be disruptive. Getting it in place, in fact, can be difficult. Managers hate DR because it's expensive, and hopefully you'll never have to use it. But it needs to be in place. Because, and this is where it gets a little bit controversial, what are the 3 top DBA tasks? What are the 3 top DBA tasks that we as DBAs are supposed to perform? Top one there. Availability. If our company is not up, running, and transacting, then we might as well all go home. The second one, recoverability. And this encompasses everything. This encompasses who here has ever run an update statement and messed up their where clause or missed it completely? Be honest. So that includes that. We need to be able to recover from that quickly. We also need to recover from a site-wide outage quickly. So availability, keeping everything up and running. Recoverability, recovering from some sort of outage, whether it be local or site-wide. And then performance. This is where it gets a little bit controversial. Third one is performance. Okay, if things all grind to a halt, that could be considered an outage. But generally, if, say, a CEO's reports are running slowly and I'm dealing with an outage, guess what takes precedence? And that can be difficult. I've had C-level people standing over me whilst I've been dealing with an outage, poking me, going, where's my report? My report's not running. And it can be hard to push back. But, sorry, Mr. C-level person, your report takes no lower priority than an actual outage. So let's start diving into these, and we'll start with high availability. So I want to talk about the difference between high availability and disaster recovery, because there are blurred lines between the two. I like to think of them as 2 sides of the same coin. So high availability. We're keeping things running. Keeping things up, keep the company transacting. We are achieving the 9s. And you'll hear people say 3 9s, 4 9s, 5 9s, 6 9s. And as those 9s go up, the amount of downtime we can have per year goes down. So 3 9s is 8.7 hours per year. 4 9s, 52 minutes. 5 9s, we're getting down now 5 minutes. And then we have 6 9s, which is, I think, 31 seconds, 31.5 seconds. So as the 9s go up, down comes down. We need to start thinking about more complex solutions, possibly spending some more money, because we need redundancy, fault tolerance, and preventing significant downtime in our systems. This is high availability. Now, when we're talking about disaster recovery, we are talking about when things have gone seriously wrong. We are recovering from a significant event. And this could be anything. This could be private data centers on fire. Could be we've had some sort of corruption with our database systems. It could be anything. We're recovering from a significant event. Downtime has occurred. And this is where we start looking at things like secondary sites. A secondary site to take over when we've had an issue with our primary. And the last point there, business decision. It's typically not our decision as DBAs to fail over to a secondary site, because we're going to be involving other teams. There's no point in us enacting our DR strategy and going, hey, everything's up and running in our secondary site, the databases are up, databases are available, and all the apps and all the networking stuff is still pointing at the primary site. We need to be working with teams in tandem to make sure everything fails over. So high availability, keeping things running, achieving the 9s, disaster recovery, recovering from a significant event. Cool. So now we can start looking at the technologies that are available to us in SQL Server. But before we do that, we need to start thinking about our recovery objectives. These define how we approach both HA and DR. And there are 2 of them. The first one being the recovery time objective, our RTO. And this is basically how long is it going to take us to recover? What is the maximum allowed time for an outage? And so what strategy are we going to use to recover our databases in the event something going wrong? This has, the same as everything, difficulty with scaling. It is far easier to recover within an RTO for a small environment that is a large environment. I worked in a company where there was literally just 2 production SQL instances, an OLAP and an OLTP. In the event of DR, we don't care about OLAP. We just want the OLTP instance up and running. We had about 20 databases on there. Biggest one was 600 gig. Backup and restore was our DR strategy, because that would achieve our RTO. We could actually restore those databases within the RTO that was defined. Worked at a company with 1,000 SQL instances. Backup and restore, probably not going to be able to do that. So we need to start thinking what other technology we can use. So that's our RTO. The other one, our RPO, recovery point objective. How much data can we lose? And this is always a fun one, because if you say to a manager, hey, in the event that there's going to be an outage, how much data are you able to lose? What is their answer? 0, 100% of the time. It's not really realistic. I actually have a colleague, hello mate, sitting over there, who, when he talks to customers, says, okay, you've got an RPO of 0. How often are you taking your transaction log backups? And they'll say 15 minutes. And I say, okay, well then you're comfortable with losing 15 minutes worth of data. It's a really tricky one to define. It's defined in terms of time. I once had a manager say to me, okay, we can lose 30 gigs worth of data in the event of an outage. What? Defined in terms of time. 15 minutes, 30 minutes, an hour? Probably not. 5 minutes, 1 minute? Again, as it comes down, we need to start thinking about more complex, possibly spending some more money strategies for our DR scenario. Okay, so let's start looking at some of the technologies. And the first one, the baseline, what we should all be doing is backup and restore. We need to be backing up our databases, and then we need to be getting those backups off-site as quickly as we can. And we should be doing this anyway. No matter what other strategies we put in place, this is pretty much the baseline for DR. Because we don't have a backup strategy, we have a restore strategy. There is no point in us backing up our databases and then not being able to restore them within our RTO to our RPO. Okay, we're backing up our databases, we're copying them off tape, and we're shipping them to a warehouse. Wonderful. So in the event of DR, what we're going to do is we're going to drive to the warehouse, grab the tapes, go back to the data center, plug them in, and then restore from them. Okay, fine, if you have an RTO of several days, that might be great. But typically, no. So we need to be able to back up our databases, get those backups off to another site. We need to be able to restore from them easily. And there are tools that we can use to do this. Everyone hear of DBA tools? Great things. You can automate scripting out our restores for us. We can use that. We can manually have runbooks with our restore scripts in. The only problem with runbooks is that if something changes in the environment, we then need to make sure our scripts are still valid, which means we're planning, we're testing, we're planning, we're testing, we're planning, we're testing. I'm going to keep doing this throughout the session. We're planning, we're testing, we're planning, we're testing. So we have our databases backed up using, I don't know, the traditional method. Everyone here, all our Halogram scripts? Pretty much the industry standard. Yeah. Backing those up SQL Server agent jobs. We keep the source backup on site for a quick restore if needed, and then we need to ship them off site. I walked into a company once that were using all Halogram scripts. They said, yep, running, and they were running their restores. They were taking their backups on the local machine and running through restores, making sure that the databases could be restored. Fantastic, great stuff. But they were keeping all the backups locally on the production VM. If that VM goes down, guess what? Not only have they lost the production databases, they've also lost all their backups. They can't restore their databases. So we need to get those backups off-site as quickly as possible. And we need to start thinking about the bandwidth between the sites. How long is it going to take us to copy across from one site to another? If it's low, it's not going to be good. In 2009 in South Africa, a company ran a test. This is back in 2009. They copied a backup, copied a load of data onto a memory stick, and then a carrier pigeon called Winston flew 60 miles from one site to the other. And they also copied the data from one site to the other across their local pipe. Guess what won? The carrier pigeon, by an hour. So we need to start thinking about bandwidth between. So great, okay, backups are going across. Again, issues with scaling. We've got a large database, in multiple terabytes, then copying it across a pipe might not be feasible for us. So we need to start thinking maybe about some more involved technologies. And the next one is probably my favorite technology in SQL Server, and that would be log shipping. You've all heard of log shipping. Been around in SQL Server since SQL Server 2000. I thought it was 2005, but it's telling me it's 2000. We take a backup of our transaction log, and we ship it somewhere else in the world, and then execute the restore there, keeping the database either in standby or recovery mode. For standby, so we can use reporting, but mostly we keep it in no recovery mode. This is tried and tested. I said it's been around since 2000, so it's 24. I'm nearly older than my car, nearly. Very mature technology, built into SQL Server, but again, this has issues with scalability. So if we have an environment with thousands of databases, it's going to take some time. If it's executing a restore one by one, one by one, one by one, we're not going to be able to achieve our RPO within our RTO. If we have a large number of transactions running, if those transaction log backups are rather large, again, the bandwidth between the two sites comes into play. Are we going to be able to copy across? This is where we could start thinking about maybe rolling our own transaction log shipping system. Who here has ever written that? Built your own transaction log? I think it's kind of a rite of passage for new DBAs sometimes. It's good because it's kind of simple and it gets them thinking about how things work. Backup, copy, restore. And with that, we can do things like parallelize the operations, maybe speed it up, customize it for our environment. I absolutely love log shipping. It's one of the best technologies in SQL Server. It's got me out of a bind when it's come to migrations quite a lot as well. Really, really handy. Back up everything with no recovery, tail log backup, ship it across, bring it up in a new environment. Absolutely fantastic. Another really good thing about transaction log shipping is that there's a delayed application of those transactions. We can control it. So say a DBA comes along and wipes out a production table accidentally. We can pause transaction log shipping, bring up the database in our secondary site, grab the data, push it back, instead of having to roll through a diff, load of transaction log restores, bringing down our recovery time objective. Cool, but as I say, we have issues with scalability with number of databases, number of transactions. So maybe we need something a little bit more complex. If our environment is large, maybe we need to start looking at some sort of mirroring technology. Mirroring, okay, everything going, really? Yes, mirroring is still available in SQL Server. It is pretty old school, but it is a valid HA or DR technology. And we have different options available to us. We have operating modes of high safety or high performance. So high safety, synchronous mode, commit on the primary, waits for the commit on the secondary, comes back to the application. Probably not applicable to us in a DR scenario because our two sites could be geographically quite far apart. So we could introduce some latency if we're doing that. So we'd probably be looking at something like high performance mode. We're not waiting for commits on the secondary, we're just firing across. Works a treat. One thing that Microsoft point out, if you go and have a look at the, by the way, all of this stuff is in the resources in the QR code, links to the Microsoft Docs, highlights, stuff. One thing it does mention is there is don't use a witness in high performance mode. You can set it up, but if you do that, what you're basically doing is setting up a quorum between the three primary, secondary witness. If you then have a DR scenario and your primary's down, the secondary needs to be able to talk to the witness, otherwise you'll lose quorum, and then the whole thing shuts down. Okay, so witness, and then in the event of a DR scenario, we've got our primary down, we're then forcing failover database by database to bring everything up in the secondary site. And again, lots of databases. We can execute this in parallel using PowerShell, but we're doing it at the DB level. And of course, we've got some custom performance metrics in there as well. So we can actually have a look at how much data we're going to lose and how long it's going to take us to recover. We have metrics like unsent logs. Now this measures potential data loss in kilobytes. Okay, we times it by 1024 a couple of times, we get gigabytes, but again, we're going to lose 30 gig of data. It doesn't really mean much to me. But then there's oldest unsent transaction. That's a lot better. That will tell us, in terms of time, how much data we're going to lose. And then we have things like unrestored log. This will tell us the amount of time it will actually take us to recover on our secondary. So that's our RTO exactly there. And then we have the mirror commit overhead. Not really applicable in high performance mode. This comes in high safety mode, and this will tell us the latency between committing on the secondary, coming back to the primary, going up to the application. It's mirroring, very valid DR strategy. However, problem with mirroring, you get a primary, you get a secondary. That's it. Maybe a witness if you're in high safety mode. So, in 2012, we got a replacement, an upgrade, as it were, to mirroring, which was availability groups. Everyone here worked with availability groups? Yeah, pretty much? Okay, cool. So, mirroring, but would you agree? Mirroring, but for a group of databases? Controversial? Okay, mirroring, but for a group of databases. Basically, we create our availability group, we drop all of our databases into it. And then we get synchronous or asynchronous replication options. And the difference between this and mirroring is obviously the group of databases, but we get up to 8 secondary nodes in Enterprise Edition. So we can have, say, in one data center, primary, secondary, and then over in our secondary data center, a couple more secondaries. And then our databases all fail over together. So in the event of a DR scenario, we are just running one command per availability group to bring our databases up in our secondary site. And our applications don't even care. They are completely unaware of the AG there. They are hitting our endpoint, our listener, and continue to hit the available databases. One thing I will say about availability groups is Microsoft recommends that you don't put more than 100 into an AG. I would lower that down to about 80. And it all depends on transactions going through and the size of the databases as well. I've worked in an environment where we had up to 600 databases in an AG. Don't do that. It was an absolute nightmare. Every time, even just trying to do maintenance on the thing, failing from a primary to a secondary within the same data center, the whole thing would fail over. You'd start to see the databases coming online, and they get about halfway, and the whole thing would go into resolving and kick the process off again. I had to run checkpoints on each of the databases before failing over to ensure a smooth failover. And if you forgot about it, you could be sitting there a while waiting for those databases to come back online. So be aware that the amount of databases and the amount of transactions those databases are having put through them can be a real factor when it comes into designing your AGs. And we also have custom performance metrics for availability groups as well. We have things like DMVs. Microsoft's got a whole big, long documentation doc where you can write stored procedures to measure RPO and RTO. And it's things like data loss equals the log send queue times 1024 over log generation rate. And fairly complicated stuff like that. Or you could just use last commit time. And that's probably a better way of working out how much data, how much your secondary is behind. So if you have a look, typical AG setup for disaster recovery. Primary, secondary, data center 1, coming over to data center 2, secondary, secondary. One thing, and this gets me all the time, is that your secondaries need to have the same specs as your primary SQL instance. If they are VMs, the hosts that your VMs are running on need to be the same spec as your primary, the ones hosting your primary SQL instances. Because what do you think is going to happen if you have an outage and you fail over to an environment where you've got, say, half of the resources, and I've seen this done. All of a sudden, everything is going to grind to a halt, and then getting back on to your original primary becomes a bit of a challenge. Okay, so that's availability groups. One thing about availability groups is they require that all the nodes in the cluster need to be part of, all the nodes in the AG need to be part of the same cluster, which can be complex, stretching across geographically distant data centers. So in 2016, we had an option for distributed availability groups. Have anyone here who's worked with, we're not supposed to call them DAGs? Anyone here worked with distributed availability groups? One or two of you. Cool. I actually really like these. But I will admit, when I first got introduced to these and someone explained them to me, it was really much a, what are you talking about? They are an availability group for availability groups. What this means is you set up 2 different AGs, and you can span your distributed availability group over the top of them, which means that your two AGs can be on two separate different clusters in each of your data centers. So it makes it a lot easier to manage. One thing, there's a little few things to watch out for these. If you're using SQL authentication for any of your logins, the SIDs for those logins have to match on each one of your nodes. If they don't match and you fail over, the login will not match the user SID. It will not map to the user in the database, sorry, and you have to go and fix it. Thankfully, DBA Tools has got a command, copy DBA login. That'll take the SID with it, and you can apply that to each one of your nodes to ensure that all your SIDs match. So if we have a look at a distributed availability group setup, a little bit different from the one in the previous slide. We've still got two data centers, still got two AGs. We've got now two AGs with two nodes in each data center, and we have the DAG spread across. We have a primary and a secondary in AG1, and a primary and a secondary in AG2. The primary in AG2 is actually called a forwarder. That's what we connect to, and it passes the transactions on to the other node. If we want to fail over, we can then manually fail over our AG to the secondary site in the event of an outage. Now, DAGs also support synchronous and asynchronous replication, but typically, for DR, we're talking asynchronous replication. We don't want any real dependencies on the secondary site coming back into the primary site. Okay, so we're talking about we've talked about all the SQL instances and all the SQL options even. But there are other options available to us. It's very easy as a DBA to get just pigeonholed into working with SQL Server technologies. And it's not always our fault. Who here has worked in an environment where you haven't had access to the storage, you haven't had access to vCenter, you haven't maybe not even got admin access to the servers you're working on, you literally just have access via Management Studio. Anyone worked in an environment like that? Yeah. If I'm going to be responsible for HA and DR, then I'm going to use the technologies that I have full control over, yeah? Because if I'm the one getting paged, if there's going to be an issue, then I'm going to use the technologies that I have full control over. I'm not going to be paged. If I get paged at 2 o'clock in the morning, I'm not going to be then ringing someone else and going, hey, I need you to enact this for me. I want control over it. But there are other options out there. Now, it's 2024. Distributed AGs, the last technology I talked about, came in 2016, so 8 years ago. Now, we're used as DBAs to, how do I put it, nurturing our SQL instances. We caress them, we stroke them, we whisper sweet nothings to them. We patch them. But do we care about those SQL instances? Do you care about them? Really? We don't care about what's accessing our data. We care about the data. Who cares what is accessing that data? So do I really want to have a secondary site where I have to go and manage all those SQL instances? Couldn't I just have the data being, say, replicated over there by some form of technology? I work for a storage company. There are loads of other storage companies. They all have similar replication technologies that you can use to get your data into that data center. And then in the event of a DR scenario, we just need something to access that data. And that could be anything. We could spin up Azure SQL Managed Instance, Azure Container Instances, or Elastic Container Service. Is it ECS? Yes. Or we could stick it into Kubernetes. We could use EKS. We could use GKE. We could use AKS. All we need is something to access that data in the event of a DR scenario that we can completely script out and have automated. So there are other options out there for us. We need to be aware of them. So we need to go and talk to our storage admins, our network admins, our sysadmins to see what else is out there. Because at the end of the day, it's all about achieving that RTO and our RPO. So we can have a look at the new technologies that are out there. I'm a big container guy. I will always advocate for stuff like running SQL Server in Kubernetes in the event of something like this, where the advantages being that we can spin up an instance of SQL Server fully configured, fully patched, ready to go on the fly when we need it in seconds. Instead of relying on something that's been there that we have to go and patch manually every now and again, make sure it's okay. When we go to spin it up, we're crossing our fingers. Cool. All righty. So let's move on to probably the most Oh, that's not right. I'd say defining your RTO and RPO would probably be the difficult ones, because you always get pushback from managers saying, no, we have to have zero data loss. Probably the second hardest bit about getting this set up is monitoring, alerting, and then deciding when to actually slap that big red button. So monitoring and alerting. What are we watching for? And what tools are we using? So, how do we define the difference between monitoring and alerting? With the tools we're using, I've used things like Nagios in the past, and if an alert pops up, I get paged, and I have to go and do something. That system needed to be highly available. It also needed to be located elsewhere than my primary data center. My primary data center goes down, and I've got all my monitoring and alerting tools in that data center. I'm going to be sitting there on a Friday night in the pub going, this is great, nothing's happening. I'm carry on having a pint, enjoying myself, whilst things are burning to the ground and I have no idea it's happening. So we need to have our tools HA, and they need to be separated from our data center. We also need to know the difference between monitoring and alerting. And I know that sounds really basic, but I've seen this happen where alerting tools have been used as a monitoring tool. Anyone here got an alerting system that has disk space alerts in it? Ah, yeah, it's got 200 gig, it's fine. Yeah, right. Alert fatigue is a real thing. Worked in places where I've had a look at their alerting systems, and there's hundreds upon hundreds upon hundreds of warnings and alerts in there. What do you think's going to happen when an actual alert pops in? It's going to get missed, because it's so used to just staring at red and orange that a new one coming in will be easily missed. My alerting systems have to be clear. If something pops up into my alerting system, it means I need to action it immediately. I need something to do. I have to do something, even. I need something to do. So, monitoring, performance metrics, trending, charting, alerting. I have something to do. I have an actionable request coming into the system that I need to go and fix. Alert fatigue is a real thing. Okay. Next one, pushing the big red button. Enacting DR. How do we decide to enact the DR strategy? We've built all these tools. We've got a wonderful DR strategy there that we've tested. Something has happened, and we're all standing around scratching our heads going, are we going to migrate to the, are we going to move over? What are we doing? What's happening? It's 3 o'clock in the morning. These things tend to never actually happen at, say, 4 o'clock on a Tuesday afternoon, apart from one company I worked with where all the systems went down on 4 o'clock on a Friday for some reason. But they tend to not happen at convenient times. It always seems 2 o'clock Sunday morning. I actually once was sitting down for a meal in a restaurant, Saturday evening, 7 p.m. My phone rang, and like the fool that I am, I actually answered it. And it was my boss who said, don't panic. All right. What happens if someone says, don't worry or don't panic? I immediately start worrying and panicking. I said, oh, the sand's gone down. Righty-ho. We didn't have a DR strategy in place. This was a company I used to work for back in Britain. One of the reasons I moved to Ireland. But our sand had gone down. It was in a private data center on site in an old converted farm. And we had a power cut, diesel generator kicked it in, diesel generator only lasted 15 minutes, diesel generator cut out, the whole thing went bang. Had to go back, get the diesel generator up and running, standing there pouring diesel into the thing for about 3 hours until the power came back on, and then we had to run through a recovery process. Thankfully, most of the databases that came up okay, had a few ones that were corrupt, non-clustered index corruption, thankfully, so it was okay. But never a convenient time. Another fun story about that one. The data center was down a hill, and every time it rained, I had to go and put sandbags outside the front door of the server room to make sure none of the water got into it. Such a good job, I decided to move to Ireland. Anyway, so we never happens at a convenient time. We need to have predetermined steps involved to say we are going to enact DR. We need key metrics in place that all the teams are aware of to ensure a smooth failover. As I said earlier, there's no point in the DBAs going, hey, we failed over into our data center, we failed over to the second data center, everything's up and running, and nothing else is there. Pointless. Everything else is still running in this first data center or have been unable to fail over, the company is still down. So we don't want any confusion. We need clear lines of communication. Working from home is awesome, but it means also that we need to have the ability to communicate with our teams clearly and effectively, whether that be Slack, Google Chat, Teams if you're really unlucky, and then, say, Zoom calls as well. And then also, we need to have a clear rollback strategy. Now, typically, we don't want to stay in the DR site. Companies that I've been in don't want to stay in the DR site indefinitely. They want to go back to the primary site. There are companies out there, if you're lucky enough to have sites out there, that they can run in wherever they want, which is great. This is how that should be done. But typically, where I've worked, it's been, we're in the DR site, we need to get back into the primary site. And that's a problem, if you think about it, because when we move into the DR site, we're down. We fail over to the DR site, something goes wrong with 5 minutes later. It doesn't really matter if we're still within the RTO, we're bringing stuff up, it's okay. We get up, we're transacting, we're good. But then we need to get back into the primary site. The company's up, the company's transacting. So how are we going to get back down into that primary site without causing massive issues? The way I do it, stick a maintenance page up, or just say, hey, we're down for maintenance, we're going to go down. The way I like to talk about managers with this is, if I go to a company website and it says we're closed for maintenance, I'll be like, yeah, cool, no worries. I'll come back a little bit later, do my transaction then. If I go to a company website, get halfway through my transaction, and I start spamming errors at me, I am never going to that website ever again. So it's about perception as well. So we need to think about those rollback strategies once we try and get back from DR site to that primary site. Okay, right, so let's round the session off, because we've been planning, we've been building stuff, we've been thinking about enacting DR, we're thinking about rolling back, we're planning. We haven't done any testing, no testing. So I want to talk about one of my favorite areas, which is not chaos engineering, it's DR testing. Why do we need to test? Again, I said, doesn't happen 4 o'clock on a Tuesday afternoon. This will happen. For some reason, 2 o'clock on a Sunday morning always seems to be my one. But it'll happen in an inconvenient moment. We might get woken up. We're going to be a bit blurry-eyed. And we need to have faith in our systems that they will work as we expect them to when we need them. And that's all chaos engineering is. The definition on the slide there is from the Principles of Chaos.org website. And all this is saying is that chaos engineering is a system, methodology, discipline, if you want, of experimenting on systems to see how they cope when they encounter failures. If they react the way we expect them to, then wonderful. We've built up confidence in our system. If they don't work the way we expect them to, then we need to go and analyze why and work out what the issue was. Now, right at the start of the session, I mentioned Netflix. Netflix back in, I think it was 2008, it might have been 2007, it was in August. And they experienced a 3-day outage, which was database corruption, actually, due to database corruption. And when they fixed the issue, got everything back up and running, they actually reworked their entire infrastructure. They went from a traditional monolithic infrastructure to a distributed infrastructure in the cloud. And when they went to the cloud, they adopted the mindset of, in order to prevent failure, we will constantly fail. And out of that mindset came Chaos Monkey. Chaos Monkey's sole purpose is to go through their production environment and randomly switch things off. The idea being here that if their systems can't handle a semi-controlled outage, how will it handle an uncontrolled outage? That's a bit extreme. It's open source, it's on GitHub. You can go and have a look at the code. You can download it and deploy it to your production environment. I highly recommend you don't do that. If in the feedback you say, hey, I deployed this to my environment and now everything's broken, I won't be sympathetic. Anyway, this is just a tool. This is a tool that they use. It was actually, I'd like to mention it because it's where chaos engineering really came from. But there are other implementations out there. There's Google disaster recovery testing. I highly, Highly doubt they actually call it dirt. They might. But it's just disaster recovery testing using automated and manual tests and controlled chaos, controlled testing. We're not going here, we're not walking into a data center and start ripping cables out the back of servers and seeing what happens. We are deliberately experimenting on systems to see how they react when they encounter failures. Slack as well is disaster piece theater, planned failure exercises. Now these could be for HA or DR. You'd start off probably testing HA and then work your way. It's called expanding your blast radius of what happens when you test these systems. Engineers working in groups, working in development, and then in production. And that's what I want to get through here is it's a methodology. Disaster recovery strategies are, at the essence, a methodology of us working together with our teams to identify potential failures and how we're going to react to them, how our systems are going to react. What do we do to ensure that the company that we're working for's databases stay up and are available to transact? And that means going to go and talk to other teams. So, as I said, it's for HA and DR. Identifying potential weaknesses and how are things going to fail? How likely are they going to fail? And what is the impact of them failing? And you could do a whole load of exercises. This can be really fun. You can go and sit down with your teams in rooms and basically say, right, how are the systems going to fail? What do we have in place to prevent the systems going down when they encounter, say, I don't know, start small. The production SQL instance database engine service crashes. What do we have in place to recover from that? And then you can start expanding out and out and out until you get to a scenario where it is a DR event. We need to enact our DR strategy, and you can start testing from there. Really good fun. So talk to your network engineers, talk to your sysadmins, talk to your storage admins, go and talk to your end users. Go and talk to the people who are running reports. Because I guarantee you, they all come up with scenarios that you won't have thought of that you can use in your testing. So working with other teams and then building experiments. That's what we're doing here. We're building experiments to test how things are going to fail. Start as narrow as possible. Pick one thing, database engine service failing, and start expanding out. Use a scientific method. We have an hypothesis. When this happens, this will happen. When the database engine service fails, the AG will fail over to the secondary node, for example. Set up proper monitoring. We can eyeball these things, but point your monitoring solutions at them because you want to gather as much data as possible so that in the event something does go wrong, you can get actionable results. Have a rollback plan. When I first started working, my first ever database job was as a systems development officer in Devon County Council, working with Oracle databases and basically just writing reports, but doing a bit of data manipulation as well. I used to show my boss, he'd be like, oh, you need to update all these rows in the table. And I'd show him the script, he'd be like, that's great. Wonderful. Put it back exactly as it was. And that stayed with me through my entire career, where anything I do, anything I work on, anything I do in production, before I go anywhere near it, I have something to put it back exactly as it was before I touched it. And that's exactly the same when we do things like these chaos engineering experiments, these DR testing, that if something goes wrong, if something unexpected happens during the test, we need to pull the plug and set everything back exactly as it was. Not flummoxing around looking for the scripts to do it. We go, right, no, test is cancelled, bang, bang, we are back as we were, we're back up and transacting. And use whatever tools you are comfortable with. If you go and start looking at DR testing sites, chaos engineering is a really good one for this. They'll be like, oh, yeah, Chaos Monkey, use the Chaos Toolkit, use this, use that, use that. No. Use whatever tools you are comfortable with. If you're comfortable with Python, use Python. If PowerShell, SQL. If you want to do it via a GUI, Windows Admin Center, use that. Be comfortable with the tools that you're using to ensure that if something goes wrong, you're completely sorted to get everything back. Okay, so what is the outcome of all of this? What are we trying to get to? Well, we want a detailed analysis of the results. If, say, our DR test has gone well, we have built confidence in our systems. We are happy that when we really need them, things will work as expected. But if they don't, we want some actionable results, because we can then go and apply them back to our systems and run our tests again to get that confidence back in our systems. And what we're doing here is building things up, increasing our confidence, so that eventually we have faith in our disaster recovery strategy. I've got some resources for you here in a GitHub repo. There's a whole bunch of stuff there. I'll leave that on the slide there for a second. Do we have any questions? Awesome. Okie dokie. We've got feedback on the slides here as well. Please do leave feedback. Let me know what you liked, what you didn't like. I would ask that you keep it constructive. Yes, of course. The question is it important for a DR strategy to be documented? 120%. Yes, absolutely. Documentation needs to be clear. One thing I didn't mention, one thing I didn't talk about, actually, that I forgot about, is who here has worked with a person who installed the system, maintains the system, fixes the system? They are the font of all knowledge for that one system. A really good disaster recovery strategy is take a disaster recovery experiment, take that person out of the room, simulate that system going down. Does the rest of the team have the resources or knowledge to fix that system? If they don't, do they then have the ability to access the documentation to be able to fix that system? And that could be anything. That could be an internal wiki. And again, where is that wiki located? If your primary data center goes down and all your documentation is stored in an internal wiki in your primary data center, that's not great. But if they have access to it, or they have runbooks or something like that, then yes, 100% needs to be documented, so that, and easily documented in clear strategy and kept up to date. Yes. Thank you.